Okay, hi students. So welcome to Shankar Medico Academy, and today I am going to teach what is the relation between the enthalpy change and then internal energy change. So this is one of the most important topic in thermodynamics if you want to solve the chemical reactions. So we should know the relation between enthalpy and internal energy change. So what is generally enthalpy? The enthalpy, if you see, so enthalpy is related with internal energy like this, H equal to U plus PV. That means the enthalpy is nothing but the internal energy and the PV work is a summation of internal energy and PV work. That is meant by the enthalpy. So generally we cannot measure in thermodynamics the exact values of enthalpy as well as internal energy. We will always focus on to analyze the change in enthalpy or change in internal energy. So the change in enthalpy I can also write as del H equal to del U then P del V. Then we know from the ideal gas equation, we know that PV is equal to nRT. Let us take the change in volume accompanies the change in number of moles of the gas. So this formula I can write as P del V as delta Ng RT. So in place of PdV, what I will going to write? I will be writing about delta Ng RT. So my enthalpy change equation becomes delta H delta U plus delta Ng RT. So R is a constant and that value we will be using as 8.314 joule per Kelvin per mole. So temperature we need to use in Kelvin. So this is the most widely used formula in thermodynamics. So this is the key relation between your delta H and delta U. Then where do we apply these things? What is mean by the delta Ng? So let us see that delta Ng is nothing but the change in number of moles of products minus reactants of gaseous species only. So that is the one of the important thing we need to know. It is delta Ng means it is for only change in number of moles of products minus reactants of gaseous species. So how do we apply this formula? So before that I want to give you one more important point. So sometimes in problem they may ask directly, okay, calculate the enthalpy change or calculate the internal energy change. But most of the problems they may ask indirect. What is the indirect way of asking the problem is, so they will give the heat of a reaction. They will give heat of a reaction. So heat of a reaction at constant pressure. At constant pressure. If this statement is there, it means what? They are talking about the heat of a reaction at constant pressure, which is nothing but your delta H. Which is nothing but delta H. So if the information is provided in your problem, so check whether heat of a reaction given at constant pressure or constant volume. If heat of a reaction given at constant pressure, it is nothing but your enthalpy change. Similarly, if heat of a reaction given at, let us say, constant volume, at constant volume, it is nothing but change in internal energy. So the problem directly they may ask enthalpy of this reaction is this much, okay, and reaction will be, you will be knowing and at what temperature it is carried out, and you need to calculate internal energy. So problem may be asked directly. Indirectly they may ask, they will be giving heat of a reaction at constant pressure, you need to calculate heat of a reaction at constant volume, or else they will be giving heat of a reaction at constant volume, you need to calculate the heat of a reaction at constant pressure. So let us see one problem. So, this is the problem given. The combustion of benzene gives carbon dioxide then water. It is a combustion reaction for the benzene. Given that heat of combustion of benzene at constant volume. So, underline this point. So, heat of a reaction given heat of combustion of benzene at constant volume is given minus 3263.9 kilojoule per mole at 25 degree centigrade. Now, what we are going to do here? We need to calculate the heat of combustion of benzene at constant pressure. See that this is an indirect problem. So, here we do not have delta H, we do not have delta U to calculate. That means they have not given a direct way, they have asked in the indirect way. Heat of combustion of benzene at constant volume, it is nothing but your del U, change in internal energy. Okay. So, what you are going to calculate? Heat of combustion of benzene at constant pressure, that means you are going to calculate your del H. So, before solving this problem, what we should know? We should have the knowledge about what is the combustion reaction of benzene. Then we need to solve, because the relation between your delta H and delta U, we have seen that one. What is that? Del H equal to del U plus delta Ng RT. So, this is a relation. So, we need to first understand what is the combustion reaction of benzene, then we need to fit into this equation to evaluate your delta H. So, what is the combustion reaction for benzene? If you take benzene, it is C6H6, which is liquid, then combustion reaction will occur in the presence of oxygen. So, oxygen is your gas, that gives me CO2, then H2O. So, H2O here is liquid and carbon dioxide is gas. Now, we need to balance. This is 1 mole of benzene undergoing the combustion and giving carbon dioxide and water. So, how do we balance? Here 6 carbons are there. Here how many carbons are there? Only 1. So, I will be multiplying by 6. Here how many hydrogens are there? 6. Here only 2 are there. So, I will be multiplying by this one. Now, we need to balance the oxygens. How many are there here? 12 plus 3, 15. So, this is my balanced chemical equation. Why I am solving this one? Because I want delta Ng. What is the delta Ng? Delta Ng is nothing but number of moles of products minus number of moles of reactants. Again, those species involving only gases. We should not write for the liquids or solids. So, what is the gaseous species here? Carbon dioxide. How many number of moles? 6. Then here in terms of reactants, we are having 15 by 2. So, this gives me 12 minus 15 by 2. It is nothing but minus 3 by 2. So, I have my delta Ng is negative value. From here only you can rule out some of the options. How it is? See that however your delta Ng is negative, correct, this R value, temperature value, if you multiply, this full term will be negative. Then delta U, already they have given, delta U is again in negative. That means my delta H will be negative value. So, I do not have option A, I do not have option B, because these are given in positive values. So, among these two only I will be having my final answer. And definitely you can also predict here without solving. How? Because you are having 3263.9 kilojoule. This value is lower than this. When you have this number, then minus of this number, both are negative values, correct? So, the number which you will get in your answer should be higher than this value. That means option C only your correct option. Without solving also you can do, but we will solve this. Okay. So, remember this one, delta Ng equal to minus 3 by 2. Now, I will apply here in our formulae. So, let us see that. So, let us go with so we have delta H equal to delta U, then delta Ng, then RT. In this case, I will be calculating your delta H, because delta U already you know, minus 3263, it is in kilojoules, I am converting into joules. So, 900 minus 3 by 2 multiply by R value is 8.314, then temperature 25 degrees centigrade, we need to convert into Kelvin. So, that gives me 298. So, if I cancel, then I will get 3263900. If you cancel these terms, so you will have 3725. So, this is negative term, this is also negative term. If you add, finally you will get minus 3267.6 kilojoule per mole. So, this is your answer. So, what we have done here? We have taken a relation between the enthalpy change and internal energy change. Then from the equation, from the chemical reaction, we have obtained the delta Ng value, and related data we have substituted here, and finally we got the delta H value. So, what I am saying is, without solving this problem also you can predict. Why? Because your delta Ng value is negative, delta U also negative, finally you will get delta H value is negative. So, hence we have ruled out option A as well as option B, because finally our answer should be negative. Then since this is already big value, another value you are adding, that means this number should be much more higher than the whatever the number. So, in that case this is also ruled out. Without solving also you can strike the option C. Okay, I hope you understood this. So, thank you.